Hello students, today I am going to start a new chapter, important chapter for JEE point of view. The title of the chapter is Permutations and Combinations. Permutations and combinations is important for JEE point of view. So permutations combination is a technique, actually mathematical technique. By using this mathematical technique you can count the things without actual counting. Students listen, permutations this one part and combination another part. By using permutations combinations you can count the things without actual counting. So what I can say here, permutations and combination is a mathematical technique. By using this mathematical technique you can count the things without actual counting. Through example I will explain. Students listen. For example, students, by using the digits 1 comma 2 comma 3, how many 2-digit numbers you can write without repetition? So simply you can say that the answer is 1 2 1 3 2 3, okay, 2 1 3 1 3 2. How many means? We can say 1 2 3 4 5 6. We can write 6 different 2-digit numbers, okay, by using the digits 1 comma 2 comma 3, the condition without repetition. Okay, how many 1-digit numbers you can write? Obviously 3 only. 1 2 3 1. Now the question is, how many 3-digit numbers you can write? Means interesting thing, 1 2 3 one 3-digit number, 1 3 2 another 3-digit number, 2 3 1 is one 3-digit number, 2 1 3 is another 3-digit number, 3 2 1 is one 3-digit number, 3 2 1 is another, 3 1 2 is another 3-digit number. How many? So I can say here 6. Here how many? Here 6. Here how many? 3. What is my question? By using these 3 digits, how many single digit numbers you can write? How many 2-digit numbers you can write? How many 3-digit numbers you can write? With the condition digits won't repeat. One thing, if digits will repeat, what happened? Single digits 3 only. 2-digit numbers 1 1 2 2 3 3. More 3 will add, totally we will get 9. Okay, here what happened, Anna? Here what happened? So 1 1 1 will get 1 2 2 2 will get 3 3 3 1 1 2 1 2 1, like that we will get several. So how to count I will explain later. So first thing is, when the repetition won't allow, how to count the things, that is case 1. If repetition allows, how to count the things, that is case 2. Nana. So first of all I want to explain the things through examples. Yeah, students listen. For example, that by using the digits 1 comma 2 comma 3 comma 4, how many single digit numbers you can write without repetition? Means I can say 4 1 2 3 4. How many 2-digit numbers you can write without repetition? I can say 1 2 1 3 1 4 2 3 2 4 3 4. Write reverse, Nana. 2 1 3 1 4 1 3 2 4 2 4 3. How many means? 1 2 3 4 5 6 7 8 9 10 11 12. 12 you can. How many 3-digit numbers you can write? How many 4-digit numbers you can write? Okay, you can count. But if you can count here also. But for example, 1 comma 2 comma 3 comma 4 comma 5 comma 6 comma 7 given. 7 digits are given. By using these 7-digit numbers, how many 3-digit numbers you can write? How many 4-digit numbers you can write? How many 5-digit numbers you can write? When repetition allows and when repetition won't allows. No difficult task. This is difficult task. So how can you count? By using the concept of permutations, you can count the such things, Nana. You can solve the such problems by using concept of permutations and combinations. That's why permutations combination is a mathematical technique. By using this mathematical technique, you can count the things without actual counting. Here 1 2 3 4 are there. I can count how many 2-digit numbers. For 1 2 3 4 5 6 7 given. How many 3-digit numbers you can write? It's difficult to write all and count, no. But logically you can count by using the concept of permutations and combinations. This is the our today's topic, students. Okay, permutations and combination. So first of all we need to complete permutation first, Nana. After completion of permutations we will start combination. permutations and combination. Before this, first of all, I want to explain one thing, important thing, that is counting principle. Counting principle. Actually, we have two types of counting principles. One is addition principle, another is multiplication principle. Addition principle and another one is multiplication principle. Sometimes addition principle is called sum rule. Sum rule. Okay. Yeah. Sometimes this multiplication principle is called product rule. Product rule. Okay. Yeah. We have two types of principles or two types of techniques to count the things. One is additional principle, one is multiplication principle. I want to explain first of all multiplication principle, addition principle. After that, multiplication principle through examples. Okay. So listen, students. First of all, addition principle. I want to explain additional principle. For example, listen, students. Yeah, this is town A. Here town B. Okay. We have three ways to travel from town A to town B. Three ways. One is airway, roadway, seaway. A person want to travel from A to B. How many different ways he can travel? Simply you can say three different ways he can travel. You can choose airway, R, important word. This is important word, R. You can choose roadway, R. You can choose seaway. Understood? R means what is the meaning of that? So he can travel in three different ways. This is one thing. For example, same problem is given another way. So A to B we have three ways: airways, seaways, and roadway. But in airway you have two types of flights, say flight 1 and flight 2. In roadway he want travel, he can use car or bus or bike. While traveling seaway also have two different ships, ship 1 and ship 2. Now you want to say how many different ways he can travel from A to B. This is interesting thing. How many different ways he can travel from A to B. So what I can say? I can say, students listen, I can say he can use flight 1. Using flight 1 he can travel from A to B. R, flight 2. R, car. R, bus. R, bike. R, ship 1. R, ship 2. So how many ways he can travel here? 1, 2 plus 3 plus 2. Totally 7 ways he can travel from A to B. Understood? So this type of principle is called additional principle. Okay. So from A to B he can travel in 7 different ways. What happened? He can travel through F1 or F2. R, F1 or F2 or car or bus or bike or S1 or S2. R, you are using R in between one operation to another operation. You are using the word R. Okay. So listen, students. Yeah, here I wrote the definition of product rule. Sum rule. Just listen what it says. If a first task can be performed in n1 ways, while a second task can be performed in n2 ways, and these two tasks can be performed simultaneously, then performing either of tasks can be done in n1 plus n2 ways. So what happened? One task is not dependent upon another task here. One task is not dependent on other task. He want travel from A to B. Okay, he can choose flight, or he can choose road, or he can choose seaway. So one is not dependent upon other independent operations. That's why here you need to use sum rule. Once again, observe this. If a task can be performed in n1 ways, a second task he can perform n2 ways. The operation of n1 is not dependent upon operation of n2. Okay, then how many different ways he can perform the total operation simultaneously, means you can say that n1 plus n2 ways. So this is called sum rule. Through example, I want to explain multiplication rule or product rule. Now you people can clearly understood what is the difference between sum rule and product rule. Okay, students, here we have three towns. Say town A, town B, town C. Town A to town B you have two ways to travel. One is airway and another is roadway. Town B to town C we have three ways to travel: airway and roadway and seaway. A person want travel from A to C. How many different ways he can travel? How many different ways he can travel? That is an interesting thing. So somebody will say that 1, 2, 3, 4, 5 ways. That is become wrong answer. 5 is not correct. How many different ways you can travel? I will show you. Observe. For example, this is a x1 route. Say this is x2 route. This is a y1 route. This is y2 route, and this is y3 route. A person want travel from A to C via B. Directly he can't travel from A to C via B. That is a condition. So what happened? One of the ways x1 y1, x1 y1, x1 y1. What is the meaning of that? A to B airway and B to C also airway. Next to x1 y2, another option. What is the x1 y2 means? What is the meaning of that? He can travel airway, after that roadway. So x1 y3, x2 y1, x2 y2, x3 y3. These are the possible options. 1, 2, 3, 4, 5, 6. What happened? x1 and y1. x1 and y1. You want travel from A to C via B. First of x1, after that y1. x1 and y1. x1 and y2. End. You are using the word end. In previous example, R. x1 and y1. x1 and y2. x1 and y3. x2 and y1. x2 and y2. x2 and y3. Okay. So what happened here? He can travel 6 different ways. What happened here? Observe. First, A to B, he can travel in 2 different ways. B to C, 3 different ways. But you want travel from A to C. How many ways means? 2 plus 3, 5 ways. This is wrong. Why you can't use a product rule? So operation, he want travel from B to C. First of all, he should travel from A to B. One operation is dependent upon another. In previous example, the dependent operations here. So here what happened? Sorry, in previous example, they are independent operations. So here dependent operations. You want travel from A to B, then only you can travel from B to C. Okay. So A to B have 2 ways. B to C have 3 ways. Okay. You want travel from A to C. How many different ways you can travel? Means I can say 2 into 3 ways you can travel. That is 6 different ways you can travel. Understood? What is the meaning of that? First of all, you can travel from A to B in 2 different ways. After completion of that only, you can start second operation. Second operation sense, you can travel from B to C. How many different ways you can travel? 3 different ways you can travel from B to C. So by product rule, we can say that from A to C, you can travel 2 into 3 ways. That is 6 different ways. What is the important thing? From traveling A to B, after traveling from A to B, then only you can travel from B to C. Understood? So one operation is dependent upon another operation. So if one operation is dependent on another operation, we need to use a product rule or a multiplication rule. One operation not dependent on another operation. First operation can perform n1 ways. Second operation can perform n2 ways. If one operation not dependent upon another, these 2 successfully can perform n1 plus n2 ways, like previous example. See here what happened? One operation can perform in n1 ways. Second operation can perform n2 ways. One operation dependent upon another. Okay, then these 2 operations successfully can perform n1 into n2 ways. Understood? Means what happened? n1 into n2. Here what happened? 2 into 3. 6 different ways you can travel from A to C. So second one is product rule. First one is sum rule. Okay. So listen. Yeah. Suppose that a procedure can be broken down into 2 successive tasks. If there are n1 ways to do the first task and n2 ways to the second task after the first task has been done. That is important thing, students. Clearly listen. He wants start task 2, he should complete task 1. One task is dependent on another task. Then these n1 into n2 ways to do the procedure means how many different ways he can complete the total task means you can say that n1 into n2 ways. Or another way, what I can say, how many different ways you can complete the total task simultaneously means you can say that n1 into n2 ways. This says the product rule. So you can generalize the product rule. First operation you can perform into n1 ways. Second operation you can perform means n2 ways. After completion of first only you can start second means one is dependent on other. These 2 operations successfully you can perform in n1 into n2 ways says product rule. So generalization of product rule. First operation you can perform n1 ways. Second operation he can perform into n2 ways. Third operation he can perform into n3 ways. Fourth operation he can perform n4 ways. Okay, one operation depend upon another, then to all these four operations successfully you can perform n1 into n2 into n2 into n4 ways, says product rule. Okay, like that you can extend up to n also, n1 into n2 into n so on, n ways you can perform the operation. So this is the concept of product rule, very important counting principle in permutation combination. Actually, so we have two types of counting principles. One is addition principle or sum rule, another one is product rule. Okay, I hope you people understood. Okay students, see here students, we have a, okay, I will delete this one minute. We have a room. This side we have 3 doors, this side we have 2 doors. A person is inside, he want come outside. How many different ways he can? What is the answer? I can say 5 different ways he can. What is the meaning of that? So this is door 1, door 2, door 3, door 4, door 5. You can use either door 1 or listen, he can either use door 1 or door 2 or door 3 or door 4 or door 5. So what happened here? One operation not depend upon another, no. That's why here you need to use some rule. For example, same person is outside the room. For example, same person is outside the room. Here, see, person is here. You want to come this side, right? Left hand side to right hand side. Left hand side to right hand side. How he can? Means what I can say? First door 1 and door 4, or door 1, door 5. D1 and D4. D1 and D5. End you are using. End in previous are no end. So now door 2, door 4, door 2, door 5, like that. So how many different ways he can that perform this operation? What I can say? Here 3 possibilities, here 2 possibilities, 3 2s are 6 possibilities. In previous what happened? 3 possibilities, 2 possibilities, that is 5 possibilities. So in this case you are using product rule, sum rule. In this case you are using product rule. Why? Because first case the person is inside, so one operation not depend upon other operation. So now person is outside, he want to perform first operation, he can perform first operation in 3 ways, second operation he can perform 2 ways, these 2 successfully can perform into 3 into 2 ways, that is 6 ways. Okay students, okay, I hope you people understood. Yeah, again another example problem. Okay students, this is an interesting example problem. Okay, so listen students, 25 buses are running between 2 places P and Q. 24 bus services are running between 2 places P and Q. In how many ways can a person go from P to Q and return by a different bus? Think it. 25 buses are running between 2 places P and Q. In how many ways can a person can go from P to Q and return by different bus? Okay, listen here. P is one town, Q is another town. The person want to travel from P to Q. The condition is, what is the condition? What is the condition? How many different ways he can go from P to Q, return by different bus? This is interesting. This is the condition. This is the condition. So what I can say, first of all, you can choose any 25 buses, bus 1, bus 2, so on. 25 buses are there, no? You can choose any one of the bus. Means he can perform first operation in 25 ways. 25 ways means you can choose either bus 1 or bus 2 or bus 3, any bus you can choose. Okay. First of all, he traveled from P to Q. Now he want return. Again, Q to P also there are 25 buses are running. Bus 1, bus 2, same bus 25. But what is the condition? While return, should not use the bus what he used to travel from P to Q. For example, he used B2 to travel from P to Q. You should not use this bus. How many possibilities are there with that person to travel from Q to P now? 24 only now. 24 bus services are possible for him to travel from Q to P. Understood? So second operation he can perform into 24 ways. First operation he can perform 25 ways. Second operation he can perform into 24 ways. So total operation he can perform 25 into 24 ways. that is nothing but 600 ways. 600 different ways you can travel from P to Q and Q to P. So while traveling from Q to P or while return journey, should not use the first bus that you use it to travel from P to Q. Okay. Generally you want to write without using permutation combination, how to write answer B1, B2, B1, B3, so on, B1, B25, B2, B1, B2, B, like that you want to write. It's difficult no to write all ordered pairs. So by using permutations concept, by using this concept, mathematical technique, directly you can get the answer. Okay. Okay students, next example, listen. By using the digits 1, 2, 3, how many 2-digit numbers you can write? Without doing anything, I can say answer is 6. Just we did know 1, 2, 1, 3, 2, 3. Reverse 2, 1, 3, 1, 3, 2 means 12, 13, 23, 21, 31, 32. These are the 6 different 2-digit numbers can be formed by using the digits 1, 2, 3 with the condition repetition won't allows. But how we can solve this problem by using permutation concept? How to solve this problem using especially product rule? Application of product rule. Students listen. So now I want to explain this problem. Take a box having 2 blanks. The two, those boxes are arranged in a row. Okay. What I want 2-digit numbers. Now what I am saying, student, just we need to fill these 3 elements into these 2 blanks. Both are same, no? Creating 2-digit numbers from 1 to 3, same as filling 3 digits into 2 blanks. Both are same. So here 1 I can write, here 2 I can write. That is 12 is the resulting number. I can write here 2, I can write 1. So 21 is the resulting number. Understood? What is the meaning of that? Just we need to fill those 3-digit distinct digits in these 2 blanks. How many ways you can fill? Those many 2-digit numbers will get. Both are same. So listen student, first I think unit digit, I can fill this box in any one of the 3. That's why what I can say, this box can be filled in 3 ways. I can use 1, or I can use 2, or I can use 3. 3 ways I can fill this box, students. That is first operation is completed. Now second operation, I want to fill this box also. While filling this box, first of all you need to complete this box. One operation depends upon another, means you need to use product rule here. So okay, so first box is filled. First box filled with either with 1 or 2 or 3. Now I want to fill second box. How many digits are left with us? That is important. Only 2, no? Any one of them is filled, no? Here either 1 or 2. For example, 2 is filled with unit digit. With us, how many are there? 1 and 3. 2 possibilities are there to fill this digit. So second operation you can perform into 2 ways. Product rule saying the total operation you can perform into 2 into 3 ways, that is 6 ways. Therefore 6 2-digit numbers you can write. See, practical also you got 6 2-digit numbers, and you know what happened by using product rule, by using permutation combination, by using this mathematical tool. Okay, by using mathematical technique, I am solving the problems without performing actual counting. Understood? Same thing. How many 3-digit numbers you can write by using these 3 digits when repetition not allowed? If repetition allowed, that is second case. We will discuss that. That is not big problem. If repetition not allowed, how many 3-digit numbers you can write? So that is same as filling those 3 digits into 3 blanks. First blank I can fill into 3 ways, any one of them. Second blank into 2 ways because repetition not allows. Third blank I can fill into 1 way. So how many ways I can fill means product rule saying that 1 into 2 into 3, that is called 6 different ways I can fill, means 6 different 3-digit numbers I can write by using the digits 1, 2, 3. This is one task, students. Next task, listen. By using 1, 2, 3, how many 2-digit numbers you can write when repetition allowed? When repetition allowed means 22, 33, 11 also we can include. So these 6 plus these 3, total 9 2-digit numbers you can write when repetition allowed. But how to solve same problem by using product rule? Students, listen Nana. So just creating 2-digit numbers by using 1 comma 2 comma 3, same as filling these 3 digits into these 2 blanks. So first blank I can fill any 3 ways. For example, I filled unit digit with 2, for example. Now I want to fill this box. This box again I can fill into 3 ways, because repetition allowed, no? If 2 use it to fill the unit digit, that same 2 I can use again, no? Repetition allowed means second box I can also fill into 3 ways. So product rule saying that these 2 operations successfully you can perform 3 into 3 ways, that is 9 ways. See, observe, 9 2-digit numbers only got now. Understood? So same problem is given. How many 3-digit numbers you can write by using the digits 1 comma 2 comma 3 when repetition is allowed? So here just filling them into 3 blanks. First blank can be filled in 3 ways. Second blank also 3 ways. Third blank also 3 ways. Totally I can fill all the 3 blanks in 3 into 3 ways, 27 ways. Now what I can say here, 27 3-digit numbers you can write by using the digits 1 comma 2 comma 3 when the repetition is allowed, students. So I can't write all 27 here, just I can say the answer, no? So that is the important thing for this chapter. Without actual counting, we can count. Actually what happened, Anna? 1 2 3 1 3 2 2 3 1 2 1 3 3 2 1 3 1 2. Without repetition, okay, 6, okay. With repetition, actually we are getting 27. What are they means? 1 1 1 2 2 2 3 3 3 1 1 2 1 2 1 1 1 sorry 1 1 2 complete 2 1 1 3 2 2, like that. But okay, number is only 3 digits. I can write all, I can count, I will get 27. That is not a big problem. If digits are again 1 comma 2 comma 3 comma 4 comma 5 comma 6 comma 7, how many 3-digit numbers you can write when repetition allowed and without repetition? Wow. Without using a product rule, how can you solve? Very difficult, no? Very difficult, no? Understood? By using product rule, you can say answer easily. That's why this technique is important. This mathematical technique is important to count the things without actual counting. Now I want to explain, students. Listen. 1 comma 2 comma 3 comma 4 comma 5 comma 6 comma 7 given. 1 2 3 4 5 6 7 digits. How many 3-digit numbers you can write when repetition allowed and without repetition? First of all, without repetition. So number of 3-digit number that can be formed by using the digits 1 comma 2 comma 3 comma 4 comma 5 comma 6 comma 7 is same as filling these 7 digits into 3 blanks. First blank I can fill into 7 ways. Second blank I can fill into 6 ways. Next blank into 5 ways. Total ways 5 into 6 into 7 ways by product rule. 30 into 7 210. Therefore 210 3-digit numbers you can create by using the digits 1 comma 2 comma 3 comma 4 comma 5 comma 6 comma 7 when repetition is not allowed. If repetition allowed, what happened? Observe, students. First blank I can fill into 7 ways. Second blank 7 ways. Third blank 7 ways. So 7 cube. There are 7 cube. 7 cube means what? 49 sevens are 49 7 what is 7 9 3 6 28 243. So 243 correct or 343 7 okay. 343 3-digit numbers you can create by using the digits 1 comma 2 comma 3 comma 4 comma 5 comma 6 comma 7 when repetition allowed. What is the difficult task? If 0 is involved, problem becomes very difficult. If 0 involved, problem is very difficult now. So I will explain what is the difficulty. Yeah, the question is by using the digit 0 comma 1 comma 2 comma 3, how many 3-digit numbers you can write when repetition is not allowed? First case, when repetition is not allowed, just filling all those 4 digits into 3 blanks. First blank I can fill into 4 ways. Second blank I can fill into 3 ways. Next blank I can fill 2 ways. So So what is the answer? 2 into 3 into 4. What is this, Nana? 3 to the 6, 6 over 24. But this is wrong answer. Why this is wrong answer? Because among these 24 digits, some numbers are there like this: 1, 0, 2, countable 1, 1, 2, 0, countable 1, 0, 1, 2 also there. Now this is not countable because this is not 3-digit number. This is treated as 2-digit number. So such numbers also involved now here, this 24, because this blank can't filled with 0, but in this 24 that blank also filled with 0. So 0, 1, 2, 0, 3, 1, 0, 3, 2, such numbers are also counted here in this 24. Such numbers should be removed. After removing that, how many numbers left? Those are the required 3-digit numbers. Okay, so 0, 3, 1 not treated a 3-digit number. But how to solve the problem, students? Listen, interesting thing. First of all, find the 3-digit number that can be formed by using all these 4, that is 24. From this 24, I want to subtract some. What type of digits I want to subtract? The 3-digit number started with 0. Actually, that not called 3-digit numbers. Just I am calling. So the 3-digit number starting with 0. First of all, I want to find how many of them are started with 0. Means this 0 should be fixed here, Nana. 0 should be fixed. Now I want to fill into 2 blanks. 0 fixed. No? With us, how many are there with now? 3 are there. I can fill this blank into 3 ways. This blank 2 ways. So 3 2s are 6. Mean there are 6 3-digit numbers started with 0. Mean the 6 3-digit numbers are counted in this 24 which are started with 0. Those should be subtracted from 24. 24 minus 6, 18. These 18 are actual 3-digit numbers, can be constructed by using the digits 0, 1, 2, 3. Students, once again listen. Actually, among these 24, some 3-digit numbers are there. They started with 0. We want to identify them. How many are there? So for to identify that, first of all, you need to take 0 as a fixed place. Its fixed place. 0 completed. Remaining 1, 2, 3. You want to fill these 2 blanks by using 3. First blank I can fill into 3 ways. This blank I can fill 2 ways. So 2 into 3, 6 ways I can fill. Means 0, 1, 2, 0, 3, 2, like that. 6 ways you can fill. 6 3-digit numbers you will get. They started with 0. So what happened? 24 minus 6, 18. 18 are actual 3-digit numbers. But what is the difficult task, Nana? Among these the 18 numbers, how many of them are divisible by 2? How many of them are divisible by 8? How many are divisible by 3? How many are divisible by 9? What is the sum of the digits of all such numbers? So such problems you can solve by using the concept of permutations and combinations. This is important and interesting chapter, students. Permutations and combination is a mathematical technique. By using these mathematical technique, you can count the things. Okay, what happened? First we have introduction. I introduced. After that, sum rule, product rule, application of product rule. This is very important. Application of product rule. I did some problems. Okay, students. Next, concept is factorial notation. Factorial notation. This is factorial notation. What is the meaning of n factorial? The continued product of first n natural numbers is called n factorial. Means n factorial means 1 into 2 into 3 into so on into n. This is nothing but n factorial. The continued product of first n natural numbers is called n factorial. For example, 2 factorial means 1 into 2, that is equal to 2. What is 3 factorial? Means 1 into 2 into, that is equal to 6. What is 4 factorial? Means 1 into 2 into 3 into 4. So what is 24? So n factorial means the product of first n natural numbers. Okay, students. So that's why I can write n factorial as pi I can write. I is taken as 1 to n. What is the meaning of that? The product of first n natural numbers. Okay. 2 factorial means 2, 3 factorial means 6, 4 factorial means 24, like that. So important note, students. 5 factorial means what? 1 into 2 into 3 into 4 into 5. Or how can you write? I can write 4 factorial into 5 also I can write. What is the problem? 4 factorial into 5 also I can write now. Or more generally 5 into 4 factorial I can write now. So 5 factorial can be written as 5 into 4 factorial. Students listen Nana. 5 factorial means what Nana? Actually 5 into 4 into 3 into 2 into both are same no? Instead of this what I can write Nana? 4 factorial. So this 5 into this 4 factorial means 4 into 3 factorial also I can write. Understood? What is the meaning of n factorial can be written as n into n minus 1 factorial. This is one thing. Or n factorial can be written as n into n minus 1 into n minus 2 factorial. Okay. So very important note. For mathematical convenience, 0 factorial treated as 1. Okay, for mathematical convenience, 0 factorial is treated as 1. We have proof for this, but generally 0 factorial treated as 1 for mathematical convenience. 0 is not a natural number, even though 0 factorial is treated as 1. This is very important thing. This is meaningless Nana, in our chapter. In this chapter, minus 2 factorial is meaningless. Okay. This is the concept of factorial. Okay. So I want to write what I explained here. One by one I will write Nana. First one, n factorial means pi symbol I is taken from 1 to n. What is the meaning of that? N equal to 1 into 2 into so on into n. This is second thing. Third thing is n factorial can be written as n into n minus 1 factorial. Fourth one is 0 factorial is treated as 1. Okay students. Yeah. Now yeah, listen, find the last digit of 1 factorial plus 2 factorial plus 3 factorial so on plus 2020 factorial, corona factorial. How to find? Last digit I want. 1 factorial plus 2 factorial plus 3 so on 202 factorial. Last digit I am asking. Last digit. How to find? I will show you. Listen. 1 factorial means 1. 2 factorial means 2. 3 factorial means 6. 4 factorial means 24. 5 factorial means 120. Interesting student. 5 factorial is 120. What is 6 factorial Nana? 6 into 5 factorial only no? 6 into 120 only no? This also end with 0 only no? 6 into 120. Okay. What I can say? 6 factorial also end with 0. I don't want remaining digits. I don't want. 7 factorial means what Nana? 76 factorial, that also end with 0 only. 8 factorial also end with 0 only. So what happened? 6 factorial, 5 factorial onwards, the last digit of the product is 0 only. Okay. So on 2020 factorial also end with 0 I can say. So I want add all, just because I want find a unit digit of addition of all these 1 factorial plus 2 factorial plus 3 so on. Addition of this, what happened? 0 0 0 only, 4 plus 3 10 13, 3 something I don't want. What happened here? I don't want here something into 3. So what I can say, the last digit of the summation is 3. Interesting question. The last digit of the summation is equal to 3 students. This is the concept of factorial notation. So one more thing I forgot to say you people, that n factorial or factorial both are same. Some books they are giving this symbol for n factorial. Factorial n, you can read as factorial n. Here you need to write n factorial. Okay. Another question. Students listen. If k equal to 1 factorial plus 2 factorial plus 3 factorial so on plus n factorial, find the possible n values so that k is a perfect square. Interesting question, students. Interesting question. So I will explain. See, if n is equal to 1, then what happened to k? K equal to 1 factorial only. That is equal to 1, which is perfect square. What is the meaning of that? N equal to 1 is the possible value, required value, one of the possible value. If n equal to 2, k is taken as 1 factorial plus 2 factorial, that is equal to 3, which is not a perfect square, just I will write a cross mark, means n equal to 2 is not a required value of n. If n equal to 3, what happened? K equal to 1 factorial plus 2 factorial plus 3 factorial equal 3 factorial 6 plus 2 plus 1 6 7 8 9, which is a perfect square. What is the meaning of that? N equal to 3 is one of the required value. If n equal to 4, what happened? K equal to 1 factorial plus 2 factorial plus 3 factorial plus 4 factorial. So 3 up to 3 factorial 9 plus 24, what is that? 33. Not a perfect square. If n equal to 5, if n equal to 5, what happened to k factorial? See, k 1 factorial plus 2 factorial, so on, plus 3 factorial plus 4 factorial plus 5 factorial. Up to 5 factorial, what I got? 33 I got. Another 120, 3, 5, 1. What I can say? 153. Not. So, interesting observation. After n equal to 4, if n is greater than or equal to 4, k always end with 3. That is interesting. Because 5 factorial end with 0, no? 6 factorial also end with 0 only, no? 7 factorial also end with 0 only, no? Okay. So, what is the meaning that n is greater than or equal to 4, k is end with 3. Means what is the meaning of that? No square number is end with 3. No? You know that no square number is end with 3. What is the meaning of that? There is no n value greater than or equal to 4. What are the possible n values? No, only 2. That is 1 and 3. Okay, I will write. Therefore, the possible n values are 1 and 3. That's all, only 2 values. Okay, I hope you people understood.